set builder and interval notation. So prior to this topic, you should have done the topic where you had to graph inequalities on the number line, so I'm assuming that you've already done that topic. I do want to do a tiny bit of a review. So what you would have learned when you graphed inequalities on a number line was that when you had something with an underline underneath it, that this translated into a closed circle on the number line. And when you had no underline underneath it, that translates into an open circle on the number line. So if I say x is less than 2, and I draw myself a number line, plot 2, there is no underline on this inequality, which means we're putting an open circle at 2, and then shading everything less than it. What's going to be new here is this interval notation. So with interval notation, this is kind of like I want to read the number line out loud. So if I could read the highlighted parts to you, I'm going to read it to you. And instead of listing all the numbers less than 2, because you'd never be able to do that, you tell the reader where the number line starts and where it ends. And since with the English language we read from left to right, the way that it works in interval notation is from left to right. So down here, you might not know what to put down here, like it goes all the way off the page. So secretly, there's negative infinity down here. And secretly, there's positive infinity up here. The thing that we're going to be using is parentheses and brackets, and before I even get into it, I'm just going to show the association. So with this closed circle and the underline inequality, this will associate with brackets in the interval notation, and this open circle and the no underline inequalities will associate with parentheses. I'm just going to tell you right now that positive and negative infinity always have a parenthesis next to them. So this might be a little confusing because you don't know what's going on right now, but now I'm about to tell you. So you're reading this from left to right. Oops, I got the wrong tool there. So you're reading this from left to right, and the first thing I see is negative infinity. So I'm going to put negative infinity down, and then you tell the reader where it stops. So I start at negative infinity, and I go all the way up until 2. Now you have to tell the reader whether or not you're including those numbers. So the reason that infinities always get parentheses is because you can't actually include you can't actually include infinity as a number. It's not actually a number, it's a concept. So we put a parenthesis on those infinities, and then this guy right here, the 2 itself, had no underline underneath it, so I'm just going to give it a parenthesis because that's what my little chart up here says. So let's do some more examples because I think that will help. If I say x is greater than or equal to, let's say -3. Here's my number line. I'm putting -3 in here just randomly. Once again, negative infinities down here, positive infinities up here. There is an underline, so I am going to fill in my circle at -3, and then it says to highlight all the numbers greater than -3, so that's this way here. Now when I read this from left to right, the first part I get to, so I want to read the highlighted part only, so I'm not reading this, there's no highlight. The first thing that's highlighted is the -3. And the highlighting goes all the way to positive infinity. Now, because there was an underline here and a closed circle, that means that we're going to get a bracket on the -3. And the infinities always get parentheses. So these guys right here, these are your interval notations. It's literally just, how can I read a number line, just the highlighted parts, from left to right? Sometimes this can be made a little bit trickier. So sometimes we have what's called a compound inequality, and let's say we have, oops, let me grab my pen, 0 is less than x is less than or equal to 5. There are now 2 numbers going on here. Move this down a little bit. So I'm drawing my number line, negative infinities down here, positive infinities up here. 0 and 5 are the only numbers I'm interested in plotting. Here's what we're going to do. Notice that 0 is next to an inequality symbol with no line underneath it. That means we're not going to fill in the circle on 0. The number next to 5 does have an underline, so when I go to plot that number, I'm going to fill in the circle. This statement itself says, shade all the numbers between 0 and 5, but don't include 0, do include 5. So if it's sandwiched like this, you're shading this middle portion right here. Now, when you read the highlighted version, you start at 0, and the highlighting goes until 5. So you're going from 0 to 5, and you're choosing your parentheses and brackets based upon whether it was an open circle or it was a closed circle. So open circle is a parenthesis, closed circle is a bracket. So open parenthesis, closed bracket. It's kind of a bad bracket. There we go. So the interval notation for this guy right here is 0, parenthesis 0, comma 5, end bracket. So this comma right here is just separating where you start from where you end, and then the end parts of it are telling you whether or not that number is included, with the only weird one being that infinities are never included. So the infinities will always have parentheses. Now you might be asking yourself, hey, this says inequality, number line, and interval notation, but what about this set builder notation? So the set builder notation really isn't that much different than this inequality notation. If I go over a slide, this right here is set builder notation, and you might be really scared about what this looks like, and I'm going to show you why you don't need to be scared at all. So first let me explain what it means. These curly braces just mean that we're talking about a set of numbers. And this part, my pointer, this part here is saying we want all numbers x, and then this up and down line means such that x is less than 3, which is cool. That's set builder notation. Really, when you're doing these problems, because we're not going to ask you to give any answers in set builder notation, you can just pretend that all of this stuff doesn't exist. And you can just look at the x less than 3 part. So now I'm just doing the same problem that I did on the previous page. I'm coming to 3. There's no underline on my inequality, so I'm going to draw an open circle. It says x less than 3, so I'm shading the numbers less than 3. There's my number line. And then for interval notation, remember negative infinities out here. Reading it from left to right, I start at negative infinity, I go up until 3, I don't include negative infinity, and I don't include 3 because there's no underline there. So this is my interval notation, and this is my number line graph. Right? Looking here at another set builder notation, I can just pretend that this whole part here, anything that's not just the inequality, I can pretend it's completely gone and just focus my attention in on the inequality part of it. So if I undo all that, this right here is the only thing you care about in the set builder notation. X is greater than or equal to 2. I come to 2. It has an underline on the inequality, which means it's included, so it gets a closed circle. And then greater than is this direction here. When I go to write this in interval notation, positive infinities up here, negative infinities down here. Reading the highlighted portion from the left to the right, the highlighting starts at 2, so I'm starting with 2, and it goes all the way up to positive infinity. 2 has a closed circle, which means he gets a bracket, and then infinities always get parentheses. So let's do one last one here. Since I did one kind of similar to this, I'm going to adjust this for a moment. let's go ahead and say we have -4 less than or equal to x less than 7. All right, so once again, I only care about this portion right here. And I'm going to go ahead and graph that. So -4 on the number line right here. The -4 part has an underline, so that means he's a closed circle. And remember, when it's a sandwich, when it's sandwiched like this, x is sandwiched between the two numbers, that means you shade the middle portion. Then I go up to 7. He does not have an underline, so he gets an open circle, and I shade everything in between. I don't even have to worry about infinities in this case because there are no infinities involved. If I read the shaded portion from left to right, I start at -4, I go until 7. -4 is included, so it gets a bracket, and then 7 is going to get a parenthesis. And that's the interval notation there. So really, the most important thing is right here, all of this stuff up in this region. You just need to know the underlines correspond with closed circles and brackets, and the no underlines, so the strict inequalities, have open circles and parentheses. ALEKS itself is going to try to give you this really long chart to memorize, and it's not worth your time to memorize that chart. It's only worth it to memorize this. That's going to be the most important part. But you guys totally got this. I totally believe in you, and I hope you have a great day.